Hello everyone. In this video, let's discuss the concept of data distribution. Python deals with the large number of data. Normally what we do is we select some samples containing 10, 20, maybe 50, sometimes 100, sometimes even 500 also. But these are considered to be small amount of data for the various examples. But in the real world, the data sets are much more bigger and it can be difficult to gather such real world data, at least at any early stage of a project. Collecting the real world data is not that easy. Sometimes we have to take some samples of that data and do the test, do the analysis, and once you are okay with the analysis, you can assume that the particular analysis is applicable to all the large set of data. So, as I mentioned, how can we get big data sets? To create big data sets for testing, we use NumPy module in Python, which comes with a number of methods to create random data sets of any size. So one of the methods of creating a big data sets using NumPy is creating a random data sets. Let's take an example here. Create an array containing 250 random real numbers or the float numbers between 0 and 5. See, for us it's something unusual. Like we may say, what is the numbers between 0 and 5? We say 0, 1, 2, 3, 4 and 5. So you may get only 6 different values between 0 to 5. But if you randomize it, you can create any number of random numbers which are between 0 to 5. Let's test the same here, which gives you 250 different real numbers which are between 0 and 5. Let's test it. So the output, as you see over the right side, contains 4.14619735, 1.9552595. So these are all the various random numbers. If you count these random numbers, the total count will be 250 as you mentioned in this example. Suppose, let me take it, okay, I want 300 different samples between 0 to 5. Yes, I am able to generate or I am able to get 300 different samples. So the total count is 300 in between the range 0 to 5. So for which I am using a function in NumPy. So as usual, I have to import NumPy. Then there is a function called numpy.random.uniform. So this function is going to generate 250 samples as mentioned over here. If you change it to 300, it will generate 300 samples in between the range. So first two parameters are the range from as well as to, and next the third parameter is how many number of random numbers you require. So this particular function will generate the random numbers between the boundaries, between the limits. So one of the very important points which we need to know about the data distribution is generation of the random numbers. Now, to visualize this data set, how do we visualize the data set? Normally, these statistical calculations, these data sets and the observations are visualized using the chart, or specifically they are visualized using histogram with whatever data which are collected. So NumPy is used to generate the data. At the same time, matplotlib is used to draw the histogram. So these two are essential for the data distributions. So a small program is explained over here. You import NumPy, as I already mentioned. At the same time, import matplotlib.pyplot as PLT, because it's very difficult to use matplotlib.pyplot everywhere. So we use alias name as PLT. We generate a list in X by using numpy.random.uniform with the two boundaries 0 to 5 with 250 different random numbers. So now X will contain the 250 different numbers. Using that, let us draw a histogram, and histogram will contain the value X, 5. 5 is a boundary. So plt.show will show this type of histogram. So this is a histogram drawn by taking a random number between 0 to 5. The total count of the random number is 250. So here let's explain the histogram. So here we use the array from the example above to draw the histogram with the 5 bars. The first bar represents how many values in the array between 0 to 1, and the second bar explains how many arrays in between 1 and 2. The third bar explains 2 to 3, fourth bar explains 3 to 4, and then fifth bar explains 4 to 5. So there are totally 5 bars in between 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So 5 bars are there: 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5 with the different values. If you analyze this graph, we get 52 values are there between 0 to 1, 48 different values are there between 1 and 2, 49 values are there between 2 and 3, 51 values are there between 3 to 4, and 50 values are there between 4 to 5. And these are not the values which are given by any programmer, but these are the values which are automatically generated by using a random function. Now coming to big data distributions. Here in the above example, we have already seen an array containing 250 different values. That's not considered very big, of course. We have taken only a simple example containing only 250 values just for the experimentation purpose, and definitely it's not considered a very big one. But now you know how to create a random set of values, and by changing the parameters we can create a big set of data set as big as we want. In the above example, we have taken only 250 values between a small range between 0 to 5. It's an example which proves that we can create as big data set as possible between any ranges. So this is a common formula used. X is equal to numpy dot random dot uniform. Inside the bracket, we can use three parameters. What are the three parameters we are using depends upon what is the number of data set we want. Maybe I am planning to get random numbers between 0 to 50 with say 1 lakh. So that means the values automatically, random values automatically are generated between 0 to 50. The total count of this values is 1 lakh. Of course, it's a big data. So same principle is used whatever we use for 250 values. So but here our range is big. Of course, the number of data whatever we get is big. So it's a big data set. So here we are generating 1 lakh random numbers which are in between 0 to 5. So the previous example also we have taken 250 values between 0 to 5, but here we are taking 1 lakh different values in between 0 to 5. So here also we can draw a histogram where the histogram takes 1 lakh different values. Let's see what's the output we are going to get. Just look at here. The upper range shows various fluctuations. So here in this example, number of fluctuations are more as compared with the previous examples. In the previous example, if I show the output, the number of variations are very less. Just look at here. The number of variation is very less. Why we get the variation, less variation? Just look at this. The variation is very less because the number of samples whatever we get is a limited sample, but in the next example the number of samples what we get is 1 lakh. So definitely we are getting a lot of variations. Now let's discuss what is the meaning of normal data distribution. So in a probability theory, the kind of data distribution where the values are concentrated around a given value is called normal data distribution. The values which are concentrated around a given value, that means suppose if you take 0.75 and if you observe the random values and the random values are very closer to 0.75, then this type of distribution is what is called normal data distribution. Normal data distribution is also called Gaussian data distribution after a mathematician who is called Carl Friedrich Gauss, who came up with this formula for this particular distribution. So normal distribution or Gaussian data distribution both mean the same, wherein most of the values or the array which are concentrated around a particular given value. Let us take an example to explain this. As usual, we are importing numpy to generate the random values, then matplotlib.pyplot to generate or to draw a histogram. So here I am generating random numbers of size 1 lakh between 5 and 1. So what I get, just look at this particular diagram. So when you look at this particular diagram, you will clearly observe that the values are concentrated, or values are very close to a particular value, right? So what is the meaning? The meaning of this is, let us observe this diagram. What is the total number of samples? What we get in this example? The total number of samples here is 1 lakh. The range is between 5 to 1. And now this is a diagram what you get. And it's very clear that the points are very closely associated with one another. See, at one particular range only, very closer range, the distribution is present. Outside everywhere there is no graph. Histogram is concentrated at one particular point. The distribution is very short here. So now here by using numpy.random.normal, we are generating 1 lakh value to draw the histogram with 100 bars. The meaning of this is, the value whatever we observe are concentrated around 5 and rarely found near 1 from the mean point. So just look at the mean point, somewhere here in the mean point, values are very much concentrated near 5. So if you go towards both the ends, the values are going down. So this is what is the meaning of a normal distribution. As I mentioned, the values are concentrated around a particular given value. This is a classic example which explains the normal distribution. So this is a classic example explaining the normal distribution. The program containing 5 lines, out of which 2 are importing, 1 is generating a random numbers, 1 is drawing the histogram. So this histogram with this value is very clear cut, which explains that a distribution is a normal distribution or a Gaussian distribution. Now let's see the scatter plot. A scatter plot is a diagram where each value in the data set is represented by a dot. The purpose of the scatter plot is just to draw a dot by taking the values from the data set. And normally scatter plots are very important for most of the statistical analysis. It could be regression analysis. It could be just by observation. So we can come to know. People can analyze just by observing the scatter plots. So to give an example, suppose if we say the Mangalore City Corporation wants to analyze the malaria diseases during which time, which period, how to prevent the malaria disease, or if the malaria disease comes, how to give the medicine, when to order the medicine, how to go ahead with the treatment. So when the city corporation as well as district health officer or the DHO should be ready for the treatment or precaution or prevention, all these things they can analyze just by getting the scatter plot. So a programmer like you and me can definitely draw the scatter point or scatter plots by taking the various samples or various data sets from the same organization. So scatter plot, it's a set of dots which are resembling the values in the data set. So the matplotlib module has a special method for drawing a scatter plot. So it needs 2 arrays of the same length. One array is what is called x-axis Another array is what is called y-axis. So if there are 10 values in x-axis, y-axis also must have 10 values. So x array represents one parameter, y array can represent another parameter. The function which is used to draw a scatter plot is scatter. Import matplotlib.pyplot, define an x array, define an y array, plt.scatter x, y, plt.show. That shows the dots over the plane, over the x and y axis, which is called scatter plot. Now, next what we are going to discuss is about random data distributions. Earlier we have discussed normal data distribution. Currently let us discuss random data distributions. In machine learning, the data sets can contain millions of values. Hundreds, thousands are not satisfactory data sets for the analysis. So normally in real world, for the machine learning applications, the data set will be in millions of values. Here, NumPy module can definitely help in analyzing this using random data distribution. So here, let me explain you the two arrays. I will be connecting the random numbers as well as scatter plot also. So basically, the concept what I am going to explain you about the random data distribution needs the application of a scatter plot as well as the application of a random numbers. So let me describe the simple program which draws 1000 different points which are called scatter plots over a x and y axis. Okay, we need NumPy, so we have imported NumPy. We need matplotlib.pyplot to draw the scatter plot. The difference what you observe between normal distribution and random number distribution is, in case of normal distribution, we draw a histogram and we take only one array of random numbers. It could be 250 values, it could be 1000 values, it could be 1 lakh values. There will be only one array containing the random numbers. But when it comes to the normal distribution or random distribution, we need two arrays. X array with one range of data and how many number of points. So in this example, we have X array with the random numbers between 5 and 1 with 1000 samples. Y array with the same random numbers between 10 and 2, once again with the 1000 samples. Take X array, take Y array, then draw a scatter plot. By taking X array as well as Y array, your random distribution is done. Just look at this example, wherein scatter plot is drawn by taking 1000 samples of X as well as Y. One is a sample from 5 to 1 range, another one is a sample from 10 to 2 range. So in that we are getting so many number of dots. If you individually count the number of dots over this plane, it is equivalent to 1000. So we have drawn 1000 dots which are called scatter points by taking X and Y samples. So this distribution is what is called random distribution. Now let us move on to the linear regression. By using these scatter points, we can draw a straight line using linear regression. Means if the points satisfy a line, then we can predict the outcome as a linear future point. If the present points satisfy a straight line, then we can definitely predict the future point which is lying on a line somewhere in the next X and Y axis. So this is what is called linear regression. For linear regression, polynomial regression as well as multiple regression, kindly go through another video which is already posted in my YouTube channel. Thank you for watching my video. Have a good day.